The James Webb Space Telescope has been revealing some of the most profound secrets of the universe. It has uncovered galaxies older than previously believed possible, along with cosmic structures that challenge our current understanding of physics. However, it has now captured something even more perplexing: an object located at the very edge of the observable universe that has left scientists baffled. This enigmatic structure is exceptionally bright, unusually shaped, and does not resemble any known celestial object. Some astronomers speculate it could be a distant galaxy unlike anything we've encountered, while others suggest it may be something even more profound, an entity that could overturn our existing knowledge of space, time, and perhaps the nature of reality itself. Beyond this, the James Webb Space Telescope has also detected irregularities in the rate of the universe's expansion. Certain objects appear to contradict the foundational Big Bang model, and some cosmic structures hint at the possibility of alternate dimensions or parallel universes. What exactly has the telescope observed? Why are leading scientists calling this a crisis in cosmology? Could we be witnessing the first evidence of a realm beyond our own universe? Let's explore these startling revelations in its recent deep field image. The telescope recorded not only distant galaxies and ancient cosmic structures, but also something that defies all current explanations. This mysterious object is far brighter than expected given its vast distance. According to established astrophysical theories, light from such a distant and ancient source should have been significantly stretched and dimmed over billions of years due to cosmic expansion. Yet this object shines with surprising intensity, as though it has been unaffected by the passage of time. What's more astonishing is its structure. Early galaxies are typically expected to be small, irregular, and turbulent. In contrast, this one appears to be remarkably organized and massive, as if it had already achieved a mature evolutionary state just a few hundred million years after the Big Bang. Some scientists believe this could represent a previously unknown type of cosmic formation, while others fear it may expose a fundamental flaw in our understanding of how the universe began. If this object is indeed as it seems, it could mean our current cosmological model is not just incomplete, it could be fundamentally incorrect. For decades, the Big Bang theory has stood as the dominant explanation for the origin of the universe. This theory holds that space and time originated from a singularity that expanded rapidly, eventually forming stars, galaxies, and everything we see today. However, the James Webb Space Telescope has now discovered massive, well-formed spiral galaxies that existed at a time when the universe should have been far too young to support such structures. According to accepted models, galaxies of this scale require billions of years to form, yet these appeared almost immediately after the supposed beginning of time. This raises disturbing questions. Could the universe be older than we thought? Or even more unsettling, could the Big Bang not have been the beginning at all? Nobel Prize-winning physicist David Gross has remarked that these findings don't represent mere anomalies, but a full-blown crisis in our comprehension of the cosmos. While some galaxies appear to behave exactly as predicted, others completely defy the laws of physics. This inconsistency suggests we may be witnessing evidence of a cosmic event that predates the Big Bang, or perhaps even signs of another universe merging with our own. As research continues, theories once confined to the realm of science fiction are being reconsidered. Among the most surprising discoveries is a set of luminous extragalactic structures that were abundant in the early universe, but mysteriously vanished later. These objects don't resemble galaxies, stars, or black holes. Their nature remains unknown. Some scientists hypothesize they could be made of exotic forms of matter or energy, perhaps a transient form of dark matter that existed only during the universe's infancy.
How?
Others entertain the idea that these may not originate from our universe at all. The long-discussed theories of extra dimensions and parallel universes are gaining new attention, now supported by observational data. Could these strange luminous bodies be remnants of a different reality, one that existed before the birth of our own universe? Even more haunting is the possibility that they still exist, just beyond the reach of our current observational tools. If this is true, then humanity may have witnessed for the first time something we were never meant to see. For generations, scientists believed the Big Bang marked the beginning of time, space, and all matter. But what if this assumption is flawed? Some researchers, such as renowned physicist Roger Penrose, propose that our universe may be part of an eternal cycle and infinite loop of creation and destruction. In this model, universes form, expand, and eventually collapse, giving birth. Two new universes in an ongoing cosmic rhythm. If accurate, then the James Webb telescope might have captured traces of a previous universe merging into our own. Supporting this idea is the discovery of supermassive black holes that appear to have formed far too early. Standard astrophysical models suggest such objects should require billions of years to reach their enormous size. Yet Webb has detected them forming mere hundreds of millions of years after the Big Bang. Some now propose these black holes did not form within our universe at all, but are survivors from a prior cosmos, leftovers from a universe that ended before ours began. If this theory holds, it implies the Big Bang wasn't a singular event, but part of a much larger and more intricate cycle. Our universe may not be unique. There may be others before us and others still to come. This concept reshapes everything we thought we understood and raises unsettling questions. If another universe preceded ours, what comes next? One of the most striking discoveries concerns a specific galaxy identified as F2OOD-B045. This structure appears to have formed merely 160 million years after the Big Bang. According to conventional cosmology, galaxies of such complexity and mass should not have been able to evolve so quickly. Yet this galaxy, located at a redshift of 20.4, is not only fully formed, but incredibly bright and massive. Its existence directly contradicts our understanding of how galaxies form and evolve. If the universe truly began 13.8 billion years ago, how did this galaxy manage to reach such a stage so quickly? Researchers are now questioning whether the universe is much older than previously believed, whether our models of galaxy formation are deeply flawed, or if there is some yet undiscovered aspect of physics at play. If future observations confirm the age and mass of F2OOD-B045, our entire narrative of cosmic history may require rewriting. However, this is not the only unusual finding. As the telescope scanned the depths of the early universe, it discovered several luminous structures that do not conform to any known classification. These small, extremely bright objects seem to have existed only during the universe's earliest phase and then inexplicably vanished. Their true nature is unknown. They do not fit the profiles of galaxies, stars, or even black holes. Some researchers speculate they could be made from exotic matter or represent primordial forms of dark energy. Others suggest they may be relics from a universe that came before the Big Bang. The most unsettling theory is that these objects could belong to a different, altogether a parallel universe. If true, then this could be the first observational proof that ours is not the only universe. And if multiple universes exist, it leads to a new set of questions. What happens when they interact? Could this be why some galaxies evolve differently? From predictions, might these objects signal the existence of vast cosmic structures beyond our observational limits? For over a century, the redshift of galaxies has supported the idea that the universe has been expanding since the Big Bang. As space expands, the light from distant galaxies stretches, shifting toward the red end of the spectrum.
Webb's.
New data is challenging this assumption. Some galaxies, observed at extreme distances, do not behave as expected under a uniformly expanding model. There is even evidence suggesting that expansion may not be consistent in all directions, contradicting Einstein's predictions. If confirmed, this inconsistency would mean that cosmic expansion is more complex than previously believed, or perhaps that it's not happening at all. Some scientists now wonder whether what we perceive as expansion could be the result of a deeper, unknown phenomenon. Could the structure of space-time itself be vastly different from our understanding? Might we be observing not expansion, but the collapse of a previous universe giving rise to our own? If time operates differently at cosmic scales, the implications for the fate of the universe are profound. For decades, the Big Bang has been central to our understanding of cosmic origins. But Webb's discoveries are causing a radical reevaluation. Some physicists, including Roger Penrose, argue that the universe is part of a continuous sequence where one cosmos gives birth to another in an eternal cycle. If this theory is accurate, then remnants of older universes should still be detectable within our own. Remarkably, the telescope may have found such evidence. The existence of supermassive black holes from the earliest epoch, previously considered impossible, now appears. To support this cyclic model,